Hey everyone, Joel here. Is it day 10 already? I think it is day 10 already. So we're going to do the advent of code day 10, or at least we're going to attempt it, and hopefully it will work. So let's check this out. Good. Look at all these colors. That's impressive. Day 10, not hash. You come across some programs that are trying to implement a software emulation of a hash based on not tying. The hash these programs are implementing isn't very strong, but you decide to help them anyway. You make a mental note to remind the else later not to invent their own cryptographic functions. This hash function simulates tying a knot in a circle of string with 256 marks on it. Based on the input to be hashed, the function repeatedly selects a span of string, brings the ends together, and gives the span a half twist to reverse the marks within it. After doing this many times, the order of the marks is used to build the resulting hash. So if we have 0, 1, 2, 3, 4, 5, pinch 5, 0, 1, twist, and then 5, 0, 1 are reversed. To achieve this, begin with a list of numbers from 0 to 255, a current position which starts at 0, a skip size which starts at 0, and a sequence of lengths. Then for each length, reverse the order of that length of element in the list, starting with the element at the current position, move the current position forward by that length, plus the skip size, increase the skip size by 1. The list is circular if the current position and the length try to reverse the elements beyond the end of the list. The operation reverses using front of the list, the current position, blah, 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 blah. Lengths larger than the size of the list are invalid. Here's an example using a smaller list. Suppose we had only 1, 2, 3, 4, or even infinite lengths of 3, 4, 1, 5. The list begins as 0, 1, 2, 3, 4, square brackets indicate the current position. First length 3 selects those, or parentheses indicate the sublist to be reversed. After reversing that selection, we get 2, 1, 0, 3, 4, then the current position moves forward by the length 3 plus the skip size. Finally, the skip size increases to 1. The second length 4 selects a section which wraps the sublist 3, 4, 2, 1 is reversed to form this current position plus the skip size total. Skip size increases to 2, blah, 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 blah. In this example, the first two numbers in the list, however, you should choose in sequence of lengths in your puzzle input. Alright, that's super confusing. It's a lot of stuff. But let's so the first thing I'm thinking is we have a state, and we're like iterating on the state. And the state involves a list of numbers, a current position, a skip size, sequence of lengths is the input, so that's not part of the state. What I would like to do is I want to make a new file. Day 10, what was this thing called? Not hash. Not hash dot py. All right, so let's do some not hash. I'm sure there's I can make a bad joke about not. Get it? Not. I'm afraid not. Not hash. Okay, that's a bad joke. Okay, so because I've been so gleefully using typed name tuples, I'm going to continue doing that because I've been having a lot of fun with that. So, and I'm going to do this state, which is going to be a named tuple. And what is the state going to be? The state is going to be a list of numbers from 0 to 255. So let's call this numbers. It's going to be a list of integers. And we're going to have a position, which is an integer, and let's call it pause. And then we also have a skip size, which is an integer. And we can use default values. So skip size starts at 0 and position starts at 0. So I'm just going to use default values for these. And you can do that, I think. I think you can do that. It's good. And so what we need to do is we need to, let's call this function step. And it will take a state, which is a state, and a length, which is an int, and it will return a new state. Okay, so this is a nice kind of functional way to approach this problem. We have a bunch of states, And you know, if we're super functional, we don't even destroy the list, but we'll destroy the list here. That's fine. So what do we want to do? Reverse the order of that length of elements in the list, starting with the element at the current position. Okay, so we have start equals, let's say state dot position, and end equals state dot position plus length mod, and let me just, I wish I had destructuring here because that would be nice. Numbers equals state dot numbers, skip size equals state dot skip size. So and I'm just going to put n equals len numbers because I want to use that. And so I'm worried about having an off by one error here. But basically what I'm going to do is I say, so let's get one of their examples. The second length for selects a selection which wraps. So current position is 0, 1, 2, 3, and then plus 4. So that goes to 7. Mod 5 is 2, which will be 1 past. So I think that's right. So let's say, you know, values to reverse equals numbers from start if start is less than end. So this means no wraparound, right? Values to reverse equals numbers start to end. I'll just do reversed values equals reversed values, and numbers start to end equals, actually if there's no wraparound, I'm just going to do this. Numbers start to end equals list reversed numbers start to end. So that's easy enough. And you know, I'll even do less than or equal to, just because. Else, so we have a wraparound, right? And so here's where I'll say numbers to reverse equals numbers from start plus numbers to end. So the idea here is that you know, maybe start is 5 and end is 2. So we want to take numbers from 5 to the end and then concatenate numbers up to 2, which I think is right. So let's say reversed numbers equals list. I think in Python 3 reverse doesn't actually return a list. It returns something that's not a list. So like if I do it's a list reverse iterator, which God only knows what that is. So so reverse numbers is a list of reverse numbers. Okay, so I reverse them, right? And then what I want to do is I want to do the following. Numbers start colon equals reversed numbers. And how many are there? That is start will be this should be n minus start. I think there's real potentials for off by one errors here, and let me just say wrap at equals n minus start. So what's the idea here? The idea here is let's say I have let's say n is 7 and start equals 5 and n is 2. So and let me just write 0, 1, 2, 3, 4, 5, 6. So we basically want to say this is the end and this is the start. And I think that means that we actually don't want that. So we actually want just 1, 2, 3. And so that means we take the first 2, which is n minus start, and then the one after that will go on the end. So I think that's right. So I'm just going to write wrap at, and numbers up until the end equals reverse numbers wrap at. And I think it will complain to me if find a slice that's the wrong size anyway. So at this point, I think I've flipped my numbers. And now, what do I do next? Move the current position forward by that length plus the skip size. So, let's say pause equals start plus skip length plus length. And again, we need to wrap around, so let's mod it by n. And finally, increase the skip size by skip length, skip size. Increase the skip size by 1. Skip size plus equals 1. And then we want to return a state with the numbers that have been beat up, and pause and skip size. So let me just call this start. That way everything is called the same. So I think we've done this correctly. So now let's do test state equals state, and so let's give this example. Numbers are 0, 1, 2, 3, 4, and we start with the other one, so that's all I really need to do. I put default values in for that reason exactly. And let's just, for length in 3, 4, 1, 5. 3, 4, 1, 5. State equals test state for length in 3, 4, 1, 5. You know what? I'm going to do this so that my states really are immutable. So I'm making a copy of the numbers, and that way when I do this, I'm not destroying my original test state. State equals step state length, print length. So I'm not running a test. I'm just going to print state at each stage. And so let's see if this does the right thing, or even gives us an error. Probably it'll give us an error because probably we made a mistake somewhere. Name list is not defined. That is easy enough to fix. Okay. So let's look at this. The list begins as the first list selects 0, 1, 2. After reversing that section, we get 2, 1, 0, 3, 4. Okay, that's correct. Then the current position moves forward by the length 3 plus the skip size 0. Finally, the skip size increases to 1. So that first step is correct. The second length 4 selects a section which wraps 2, 1, 3, 4, 0. The sublist. Okay, so definitely it's gone wrong at this point. So let's print start and numbers and rerun it and see what happens. So somehow that did not wrap around. And why did that not wrap around? Because I did not use a parentheses. Okay, so I wanted to mod the sum of those two things, and without the parentheses, I just modded the second one. Let's see if any of my other mods are wrong. No, that one looks okay. Okay, good. So let's try running this again. Okay, this is different at least. So the second length 4 selects a section that wraps, and it becomes 43012. Then third list 1, 43012, 5 selects every element. And then we missed this one too. The fourth length 5 selects every element starting with the second. Reversing this sublist because okay, that's an interesting edge case which we missed, which is I did this less than or equal to, but what I really want is less than, because when start equals end, I actually want to treat it as a full wraparound, and there I was treating it as not a wraparound. So I think if I do that one now, I get 3, 4, 2, 1, 0, skip size increases to 4, and position 4. So, so I think that's the right thing. That's a very small input. Okay, good. So before committing to this, let's play with it and see what happens. So I'm going to comment this out and say if name equals main, lengths equals I spelled that wrong. Lengths and let's say state equals state list range 255. So or 256, I think they said. Let's check that out. We should use list size of 256 and the sequence of lengths. Once the process is complete, what is the result of multiplying the first two numbers in your list? For length in lengths, step state length, print state. So that's good. And what I would like to do is I would like to make this printing a little bit more verbose so we can really understand what it's doing. So I'll do start, print end, print numbers is fine. And let's, print, let me print the length in between these two too. Print length is length. So let me run that and see what happens now. All right. So we start 0, length 199, end 199. So what that should do is that should reverse everything up to 199, which it seems not to have done. Okay, this doesn't seem to be affecting anything, so that's not good. And am I just printing the wrong state? Well, that's part of the problem. It's that that's the problem with doing things in an immutable way. If you don't capture the result, then it won't work. Okay, So start 0, length 199, and 199, and then when I get this state, it takes the numbers from 0 to 198 and reverses them, and then it goes up to 199. That's good. And then the second one, start 199, length 0. So it is length 0. So presumably after doing... so is that the right thing, length 0? Because it just reversed them all again, the way it did when... So it looks like this test is if start is less than so you know what, if length equals 0, then I don't think I want to do anything, so I'm just going to do pass. Because there's basically two ways where you can get start equal to end. You can get start equal to end if you pass in 0, or if you pass in the whole list. And you want to do different things in those cases. If the length is 0, then as I understand it, reverse the order of that length of elements in the list. If I say reverse 0 elements, that means don't do anything. If I say reverse 256 elements, that means do a lot. So I think we need to special case that. And I don't think I actually need to print the numbers because they're being printed in the state anyway. So let me run that again. And I know what the initial state was like. So, I start with my numbers. I do start 0, length this, and 199. So we agreed that that one was pretty good. Now we do length 0. I think we agreed that length 0 we didn't want to do, and we bumped up skip size to 1. Length 0 we don't want to do anything, but we add that 1 from the skip size to the pause and bump up skip size to 2. Now we start at 200. The length is 255, so that means we end at 199, and we want to I don't even know how to check this, but so if I start at 200, which is this 199, 200. So if I start at 200, that's actually here, and I want to end there. It means I want to basically leave that 0 where it is, I think, and then reverse everything around that 0. So once I do that, I basically reversed everything around the 0, which seems like it did the right thing. And that 0 is in position 199. I skip up to 201, 136, 81. I don't really even know how to check this, but let me just add in that one unit test. Let me do that. Assert that state equals state of, and then what do we say this one was? Just 34210, 34210, and skip size is 4, and current position is 0, 1, 2, 3, 4. So let's try this again. We passed our assert. And print state 0 times state 1, which is I think what we wanted to do. And why is that not? Because state dot numbers 0 times state dot numbers 1. Okay. 3770, so 65 times 58. 3770. All right, so do we feel good about this? Let's try it, 3770. That is the right answer. Good. Okay. Oh man, part 2 is long. All right. The logic you've constructed forms a single round of the not hash algorithm. Running the full thing requires many of these rounds. So I'm going to go back and take some of these print statements out because I think there's too many of them, and they will get in our way when we're trying to do the second part. First, from now on, your input should not be taken as a list of numbers, but as a string of bytes instead. Unless otherwise specified, convert characters to bytes using your ASCII codes. Okay, this seems like kind of a pain. Python get ASCII code. Board gets the int value, so let's make sure that that is correct. For example, convert characters to bytes using their ASCII codes. This will allow you to handle arbitrary ASCII strings. Also ensures that your input lengths are never longer than if you 1, 2, 3, convert the ASCII codes for. Okay, I don't understand this at all. Word 1 is 49. That's right. Word 2 is 50. Oh, I see. It's using the comma. That's where that 44 comes from. So if you're given 1, 2, 3 to convert the ASCII codes for each character, it ensures that your input lengths are never. Oh, I see. Now I understand. Once you've determined the sequence of lengths to use, add the following lengths to the end of the sequence. For example, you're given 1, 2, 3. Okay, so let's just write that function. Let's say def. I'll call this encode. Some string becomes a list of int, and I just want to return board C, 4C, and S plus, and then they said I want to add these links to the end of the sequence. Okay. So assert that encode of 1, 2, 3. 1, 2, 3 is, and here we're solving part of this problem before we read the whole thing, which is okay. I'm going to comment this out as well, and this, and let's just run that and see if it works. Okay, so that passes, so that's good. Second, instead of merely running one round, run a total of 64 rounds using the same length sequence in each round. The current position and skip size should be preserved between rounds. For example, if the previous example is your first round, you would start your second round with the same length sequence. Now, assuming they came from ASCII codes and include the suffix, but start with the previous round's current position and skip size. Once the round, okay, that's fine because we already basically are doing that. Once the rounds are complete, you'll be left with the numbers from 0 to 255 in some order called the sparse hash. Your next task is to reduce them to a list of only 60 numbers called the dense hash. To do this, use numeric bitwise OR to combine each consecutive block of 16 numbers in the sparse hash. For example, if so let's write that function, I'll call it XOR16. XOR16 x's, which is a list of int, and it's going to return an int. And we're just going to XOR all 16 numbers together. And I'll just do it and assert that the length of x is equal 16, because otherwise that's not true. result equals x is 0 for I in range 1 to 16. Result equals result caret, and that's that should be numeric XOR, I think. X is I, and so instead of, okay, that's bad Python. For x in x is 1, that's better Python. Result equals return result. Okay, so I could probably do that with like a functools reduce, but not supposed to use functools reduce. So if the elements of your sparse hash are as shown below, and the XOR operator is this, so assert XOR 16 of, and now I wish they'd just give me a list instead of doing comma. Should probably do a search and replace, it would be faster, but I didn't. So you can watch me type all these commas and delete all these carets. And this is supposed to equal 64. So let's run that, and that assert passes. So that means my assert 16, or my XOR 16 is probably pretty good. And now let me write another function on each of the 16 blocks. We call it sparse to dense. Def sparse to dense of some x's, which is an int, and sorry, is a list of ints. And so what I want to do is I want to break this. So again, I'm going to assert that len x's equals 256 because we've said it's always going to. And what I want to do is to say, for start in range 0, 256, go by 16. And what did we call these? Each block. So, block equals x's start to start plus 16. And let me just do this all in one. Return XOR 16 of, so this will be smooth, for start. So I don't know how to write a good test for this, but here's a bad test for it, basically, is that just to check that it's basically doing the right thing, assert sparse to dense of, so if I have 16 copies of the same thing, that should equal 64 times 16. So so it's doing something right there. Finally, the standard way to represent a not hash is a single hexadecimal string. The final output is the dense hash in hexadecimal notation because each number in your dense hash will be between 0 and 255 inclusive. Always represent each number as 2 hexadecimal digits, including a leading 0 if necessary. So if your first 3 digits are 64, 7, 255, they can correspond to the hexadecimal numbers. Okay, so let me Python to hexadecimal. I don't know off the top of my head how to do that, so we will Google it. How to convert an X to CHR. Use the hex built in. So what is the hex built in? Hexadecimal declaration of integer. So hex 1, hex 255. So that's not the format that they want. The format they want is basically Okay, well, let me, I'll call it hexit is going to be x is an int and goes to a string. And so let's just say, h equals hex of x. And so now, h will be either 0x1 or 0xff, something like that, right? And so, let me call this hex returns something like this. We need to throw away the first two characters because we don't want that 0x. There's two cars, and maybe add a leading 0. So first, let's throw away the first two characters and return h if len h. So let me just assert len h. Assert 1 is less than or equal to len h is less than or equal to 2. Did you know you can do that in Python? You can. It's clever. Return h if len h equals 2, else 0 plus h. So let's assert that hexit of and 64 equals 40 in a string. Assert that hexit of 7 is 07 and assert that hexit of 255 is FF. Okay, so let's run this again. All those pass. Good. So here are some example hashes. What is the not hash of your puzzle input? Ignore any linear trailing white space you might encounter. Okay, so let's try and write this not hash function. Not hash is going to take some s, which is a string, and it is going to return actually a string. And so it says ignore leading spaces. So let's just say s equals s dot strip. That will get rid of those spaces. And now what do I want to do? Okay, convert characters to bytes using their ASCII codes. And we wrote a function for that, right? We wrote a function called encode. So I'll say bytes. I'll do this because it's a built-in word. Bytes equals encode s. Okay. So now this is a list of ints, and once you've determined the sequence of an encode, I think added that other thing too, right? So that's actually I'll call that length because that's actually the length. Length is going to be encode s. Okay. Got the length. Instead of run 64 rounds using the same length sequence in each round. Okay, so 4 rounds in range 64. Oh, and let's start a state. So state equals state num for num in range 256. That's different from how I wrote it before, but this is probably just as good. So what do I want to do? I want to, and I think I call my function step. Is that right? Yeah. So and then I need to do for length in lengths. State equals step state length. So that will go through my 64 rounds, and at that point I have a sparse hash. So let's say sparse hash equals state dot numbers, and we want to reduce these to a list of only 60 numbers called the dense hash. So we wrote this function called sparse to dense. Dense hash equals sparse to dense of sparse hash. Okay, and now we've got a dense hash. Finally, we want a single hexadecimal string. We want the dense hash to so. What we want is we want to return. We basically want to, hex it x for x in dense hash. So that will give us a list of. That'll basically give us a list of strings, right? Each one will be a 2-character string, and anyway, so here are some example hashes. So let's do these test cases, and probably if these test cases work, assert not hash of an empty string equals this thing, and I'm curious how it will handle the empty string. So I don't think we dealt with that case specifically. So if I have an empty string, it'll just create no lengths, and then it'll add those few that are on the end, right? It told us to add a few, so it'll always do something. And why am I using single quotes today when I normally use double quotes? I have no idea. That's just what I started typing, and that's how it came out. So, let's see what happens. Ah, look at that. That's pretty good. So our puzzle input has not changed. But I lost my puzzle input somewhere. Let's get my puzzle input. So if name equals main, s equals this, print not hash of s. I think that's it, right? So now we're treating this as a string. It's a string, and all I want to do is print the not hash of it, and I got this thing. So I hope it works, because if it doesn't work, I don't have a real great sense of how I would debug it. So let's try it. That's right. Answer 1 gold star, closer to debugging the printer. That one was actually a little bit more involved. It's fun to watch this thing light up, and we can't do problem 11 yet, but it worked. So I hope that was interesting and educational. And as always, you can find me on Twitter at Joel Grus. Thank you for watching, and we'll do another one of these soon, as soon as it comes out. So thanks.